All right, we've got a Chapter 13 test coming up. Here is the review that we're going to do in class. Number 1, triangle CAB has dimensions shown. Write your answer as simplified fractions or decimals rounded to the nearest tenth. All sides are on the triangle. So we're going to go to angle C and find the tangent. Tangent is the opposite side over the adjacent side. So 7/3 would work there. What is the sine of angle A? Well, here's angle A. Sine is opposite over hypotenuse. That'll be 3 over the root of 58. As a decimal, that's about 0.4. And then back to angle A, cosine. So here we are at A. Cosine is the adjacent side over the hypotenuse. So that'll be 7 over the root of 58, which is about 0.9. And on to question 2. Find the missing side lengths. It looks like we just need to find one missing side. So if we're at the 70-degree angles perspective on this triangle, we have the opposite, or we want the opposite, and we have the adjacent. So that's going to require tangent. The tangent of 70 is opposite over adjacent. Multiply both sides by 6. So our answer is the tan of 70 times 6, which is about 16.48. On the other triangle over here, we're at the 31-degree angle. We have the opposite, and we want the hypotenuse, so that's going to be sine. The sine of the 31-degree angle equals 11 over x. So we're going to multiply and move the x over here, and then we're going to divide by the sine of 31. So if we punch that into the calculator correctly, you're going to get about 21.36. Number 3, we've got triangle JKL. L is 53, J is 90, KL is 11 feet. Draw a picture to represent. So I'm going to draw my right angle over here on the right. And the right angle is angle J. Angle L, L and K are the other two. It doesn't matter if I put L here and K here or vice versa, because LK will always be the hypotenuse, and KL is 11 feet. So there's our picture to represent. Oh, I got to put in angle L is 53 degrees. Part B, what is the perimeter to the nearest tenth of a foot? Well, the perimeter is all three sides added together. So our perimeter is going to be 11 plus this leg plus the other leg. I'm going to go back up to my triangle, and I'm just going to call this x and this y just for convenience. So if I'm at angle 53 and I want the opposite side y over the hypotenuse, that's going to be sine. The sine of 53 is y over 11. And then y is just 11 times the sine of 53 degrees, and that's about 8.78. So I'm going to put that down here, 8.78. And now we got to get side x from 53. X is adjacent, and we have hypotenuse, so that'll be cos. The cos of 53 is x over 11. Multiply both sides by 11, so that'll be 11 times the cos of 53, which is approximately 6.62. So I'm going to put that down here, 6.62. And if we add all those up, and we'll round it to the nearest tenth, we're looking at about 26.4 feet. All right, let's see what number 4 looks like. Measure of angle A to the nearest 10th degree. So let me blow this up a little bit here. So we want to find the measure of angle A. And the sides we can easily count is this one. 1, 2, 3, 4, 5, 6, 7, 8. This side is length 8, and this side is length 4. So if we're at A, we have the opposite, we have the adjacent. That means tan. The tan of angle A is 4 over 8. So of course, to get rid of tan, we're going to tan inverse Angle A is the tan inverse. We can reduce 4/8 to a half. So we punch that in our calculator, and we get angle A is about 26.6 degrees. All right. Number 5, we have another triangle. Looks like we're going to have to draw it. So angle D is 90 degrees. Oops. D. And the other two sides are E and F. I'm going to put it here. I'm going to put this here. Now it says DF is 8 inches. EF is 12 inches. What is the measure of angle E to the nearest degree? So if we're here at E, we have the opposite. We have the hypotenuse. Opposite and hypotenuse mean sine. The sine of angle E is 8/12. So angle E, the measure of angle E, will be the sine inverse of 8 divided by 12. So angle E is approximately 41.8 degrees. Now in the next one, what is F to the nearest tenth? If we're confident in our angle E, angle F is just 90 minus angle E, which would be 41.8. And then angle F is then 48.2. The other way we could have done that, up here at angle F, we have the adjacent, we have the hypotenuse. We could have done the cos of angle F is 8/12, and then cos inverse, and we should have got the same 48.2 degrees. All right, number 6. This one can be tricky. We just got to make sure we read the problem maybe a few times to see what's going on. Triangle ABC. A is the 90-degree angle. So I'm just going to call this B and this C. Now here it says cos of B is 0.8. Cos of B is 0.8. Well, they kind of handed this to us on a silver platter. We've got the cos of an angle is equal to this value, so let's cos inverse. Angle B will then be the cos inverse of 0.8. And the cos inverse of 0.8 is roughly 36.9 degrees. So angle B is 36.9. If we subtract that from 180, from 90, we're going to get angle C down here is 53.1. Now let's go back and reread the question. What is the value of sine C? Well, here's angle C. So the sine of C is just the sine of 53.1. And on our calculator, that's about 0.8. I think I remember pointing this out in class. The cos of one angle will be the same as the sine of its complement. Our angles, these acute angles here, 36.9 and 53.1, are complements, and the sine and the cos of complement angles will be equal. So they are both 0.8. All right, now on to the special right triangles. So the one on the left here, this is a 45, 45, 90. Remember, in a 45, 45, 90, the ratio is leg x, hypotenuse, x root 2. So if this leg is 13, x also has to be 13. And then to jump to the hypotenuse, we multiply that leg 13 by the root of 2. If you prefer a decimal, that's about 18.4. Now over in the other triangle, that's a 30, 60, 90. The ratio here is short leg x, long leg x root 3. Hypotenuse is twice the short leg. So let's see what they gave us in the picture. Across from the 60-degree angle, our length is 21. So here, we're going to set this, x root 3, equal to 21. And if we get x alone, it would be by dividing by the root of 3. And if we just want to get that as a decimal, 21 divided by the root of 3 See, that would be 12.12. So again, that would be then this side, the short leg, is 12.12. Now that we've got the short leg, 12.12, we would double that to get to the hypotenuse. Double 12.12, that's 24.24. All right. Okay, here's some more special right triangle stuff. We got two sides here, and then we got all three sides. Does it fit 30, 60, 90, 45, 45, 90, or neither? Well, again, remember for the 45, 45, 90, it's x root 2. So here's an x, here's the same x times the root of 2. So that fits the form for 45, 45, 90. For 30, 60, 90, short leg, x, long leg, x root 3, hypotenuse, twice the short leg. So let's look at both of these simultaneously. Here's my short leg. If I double it, there's my hypotenuse. Here's a short leg 7. If I double it, I get my hypotenuse. So it comes down to the long leg. Notice in the 30, 60, 90 triangle, our radical here is a root 3. So it looks like this bottom one is our 30, 60, 90. And this one then wouldn't fit either of those formats. All right, now some applied problems. Let me get a quick dotted line here. So we got a pilot flying a helo, locates a person on the ground. The horizontal distance is marked here, 950. Altitude of the chopper is 500. What is the approximate angle of depression from the chopper to the person? So here would be the hypotenuse of our triangle. Remember, a lot of times the angle of depression is outside. So here's our vertical or our horizontal line. This is what we're trying to find. That blue question mark, our angle of depression. So how we're going to find it first is to find our angles inside the triangle. And it would probably be best to find this angle first. Luckily, we have the opposite side and we have the adjacent side from that angle. So I'm just going to call it angle A. The tan of angle A is opposite 950 over adjacent 500. So we are going to take the tan inverse of that. So our tan inverse of 950 divided by 500, we get x is about 62.2 degrees. So again, remember that is the angle inside the triangle, 62.2 degrees. Now this angle up here with the helicopter, this would be a right angle. So to find our blue here angle of depression, we're going to do 90 minus 62.2, and that's going to be about 27.8 degrees. So there we found our angle of depression. All right, number 10. I got a person here sitting on the end of a pier, and they see a crab crawling on the ocean floor. Well, here's my crab. There he is. The person's eyes are 6 feet above the surface of the water. So here I'm going to use, well, I should maybe not use dotted line. And I'm going to use red and thicken it up. The person's eyes are 6 feet above the water. So this distance is 6 feet. And again, it ends right here at the water line. The person's eyes are 6 feet above the surface of the water and 16 feet from the crab. So here we're going from the eyes again down to Mr. Krabs, and that distance is 16 feet. If the angle of depression, let me get another line here. So there's my blue dotted line for my horizontal line. The angle of depression from the person's eyes to the crab is 65 degrees. So this is a 65-degree angle, and again, this angle of depression is outside our triangle. Here's our right angle down here. So 90 minus 65, the angle inside our triangle is 25 degrees. So what we're going to do here This is our hypotenuse, the 16, and we can set up a trig function to find this entire side that I'm scribbling over in black. So that side there would be adjacent. The 16 is the hypotenuse. Sounds like a job for cosine. The cosine of 25 degrees equals adjacent, let's call it x, divided by hypotenuse 16. And if we plug that into our calculators, we should get our x, again, which would be this entire side here, is about 14.5 feet. So this entire side is 14.5 feet. Our final question is, how far below the surface of the water is the crab? So we want to find this distance, which just so happens to be the same as this distance here in blue, and that's as easy as doing the 14.5 minus the 6 foot, which means the crab is in about 8.5 feet of water. Okay, one more, grand finale. A child sees a bird in a tree. The eyes of the kid are 4 feet above the ground. So this dot here, it's not the kid, it's the kid's eyes. I'm going to do it like this. Maybe he's a little angry. I'll give him some angry eyebrows. Those eyes are 4 feet above the ground. 4 feet. The eyes are also 12 feet away from the bird. So if the eyes are here in blue and the bird's up here, this side length would be our 12. And the child sees the bird at the angle of elevation shown. So there's our 40-degree angle of elevation, and we can complete off. This would be our right triangle. Our final question is, what is the bird's height above the ground? So here's the ground. We want to find this entire height. And, you know, here is our 4 feet that the eyes are above the ground. So in a rectangle, this would also be 4 feet. So the overall height, it looks like we're going to have to find this red side. And from the 40-degree angle's perspective, the red is opposite. We have the hypotenuse. Opposite and a hypotenuse means sine. The sine of 40 equals x over 12. So we're going to multiply both sides by 12. Our x is 12 times the sine of 40. My calculator tells me that x is about 7.7. So again, here this red piece is 7.7 feet. And below that, we got 4 more feet. So let's add those together and get 11.7 feet above the ground is the height of the bird. And that is the end of the review. I hope it gets you ready for the test we're going to have tomorrow.